Lesson 36, 36C, Boat in the River Problems. And we have one practice problem to do with this. In order to do this problem, we've got to remind ourselves of the whole dirt. Remember dirt? Distance is equal to rate times time. Well, in our boat in the river problems, our rate is going to be two speeds acting either against each other or with each other. So remember when you have a little boat, right? And if you're in the water with your little boat and the current is traveling this way, right? And you are traveling this way, then these two speeds are added together because this is carrying you in addition to how fast you're going. So it makes sense that if you're going downstream, which is the direction that the current flows is downstream, right? We're going with the current. Then the two rates are going to be added together. The two speeds are added together, and that becomes the rate part of our rate times time equals distance. However, if you're in a little boat, right, and the current is going downstream, but your little boat, you want to go this way, you want to go against the current, then what's going to happen is you're traveling at a speed, but then the current is pushing against you, right? So that means we have to deduct the speed of the water or the current away from the speed of the boat because it's pushing the boat backwards. And that becomes the rate of the, in the rate times time equals distance problem, just like this one does. Right? So we have two different ways depending on the scenario that we are given. We have to know whether or not the boat is traveling upstream or whether or not it's traveling downstream. And then that tells us which one of these to use in the given situation. So let me put 36.4 up here. So here's our problem. One day Selby found that her plane could fly at 5 times the speed of the wind. She flew 396 miles downwind in half an hour more than it took her to fly 132 miles upwind. What was the speed of her plane in still air, and what was the speed of the wind? So this is very much like a boat in the river problem because we have a current acting against or another rate of speed acting against and helping the plane. We have the current of the air. So the plane is like the boat and the air is like the water. So we treat it that way, right? So let me bring this up so we can just have as much room as we possibly can. So the first thing we're going to do is figure out how we're going to write our equation. So let's write the downwind equation first. So downwind, that is the same thing as the downstream. So we're going to be adding the speed of the wind to the speed of the plane. So that is going to be, let's use S for the plane because that's Selby, because Selby's flying the plane. So Selby plus the wind times the time downwind is equal to the distance downwind. And her upwind equation is going to be the same thing except it's going to subtract. So Selby minus the wind speed times the time upwind is going to equal to the distance upwind. Now we're going to substitute in the speed of her plane, which is 5 times the wind. So Selby's speed is 5 times the wind plus the wind. And her time, according to, this is in parentheses as well, her time, according to the second sentence, was that she flew 396 miles. So that's our distance for downwind, half an hour more than it took her to fly 132 miles upwind. So the time upwind plus half an hour is going to be equal to the distance downwind, which is 396. Now upwind It took her 132 miles upwind. So her speed is 5 times the wind minus the wind. And we don't know what the time upwind was. We just know it was the time upwind, but we do know the distance was 132 miles. So now we have our two equations set up. We can distribute at this point. So we have 5 times the wind plus the wind. That's going to be 6 times the wind times the time upwind plus half equals 396. So that's going to be 6 times the wind times the time upwind plus 6 times 1/2. That's going to be 3. So 3 times the wind is equal to 396. So that's that one as much as we can go right now. So now let's do this one. So 5 times the wind times the time upwind. So I'm sorry, got tongue-tied. 5 times the wind, or 5W minus W, that's going to be 4W times the time upwind is equal to 132. All right, so now we know what 4WTU is equal to. So we can actually divide that by 4 because we have a known quantity there. So a WTU is equal to 33, I believe. Yes, 33. Because 4 times 3 is 12, carry a 1, 12, carry the 1 is 13. All right, so WTU is 33. So now we have a value that we can substitute in here. So 6 times 33 plus 3W is equal to 396. 6 times 33 is 198 plus 3W equals 396. If I subtract 198 from both sides, then 3W is going to be equal to, it's going to be an 8. It's going to be 298 or 198. Is that right? Yeah, that's 198 because it's half. So if I divide both sides by 3, W is equal to 66. So the speed of the wind is 66. And if her speed is 5 times 66, so Selby is equal to 5 times W, and W is 66, then Selby's speed is equal to 330 miles per hour. So those would be your two speeds, 330 miles per hour for Selby and 66 miles per hour for the wind. And that's how we would solve two problems the problem like that with boat in the river as applied to a plane on the wind or in the wind or flying around wherever. Okay. That is the last problem, example problem that we have for lesson 36 in 36C. If you have any other questions, please feel free to ask. Complete the practice problems that are following if you are logged in to Jupiter Ed and following along that way. And I will see you in lesson 37.